Hello, let's continue our Sudoku adventure with Shrug by PjoeterBliep. So we have 6x6 normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have non-consecutive global constraint. So any two cells in the entire grid that are adjacent to each other, i.e. they share an edge, may not contain consecutive digits, meaning they can't have a difference of 1. So, for example, if this was a 2, this is not allowed to be a 1 or a 3 because that would put two consecutive digits next to each other. That's the same thing here, same thing here, same thing here. You can't put 1s or 3s around the 2. All right, so no consecutive digits at all in any two orthogonally adjacent cells. In addition to that, we do have these German whisper lines in the grid. Any two adjacent digits on the line have to have a difference of at least 3. So if this was 2, this could be 5, which has a difference of 3, or 6, which has a difference of 4. What we can't do is say a 4, because that is a difference of 2. 4 minus 2 is 2. That is not at least 1. Now, the order doesn't matter, so this also can't be a 4. And we just take the bigger minus the smaller. That's 2. That is not a difference of at least 3, and so that's no good. And then this cell here is odd, 1, 3, or 5. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Start by putting 1, 3, 5 in here. All right, almost done. Now there is a property of non-consecutive in 6x6 that I could use, which would probably trivialize the puzzle, but I'm not going to use it because it's actually kind of hard to prove. And I tried to work through, before I started this puzzle, I tried to work through the proof of it. But I couldn't remember how to do it. I think it was actually kind of difficult to do. But it's easy to prove with Computer Solver. But anyway, I will, at the end of the puzzle, so I'm going to leave you hanging here. At the end of the puzzle, I will tell you what that property is. All right, so we have this 1, 3, 5 here. And that's, again, it's only for 6x6 puzzles with standard boxes. Anyway, I'm going to color the German whisper line. What do I mean by coloring? Well, we're going to represent lows and highs. A low, so we're going to segment our 1 to 6 into lows, 1, 2, 3, and highs, 4, 5, 6. We're going to say, okay, what if a low was somewhere on a German whisper line? Well, if a low is somewhere on the German whisper line, the one next to it, or ones next to it, must be high. Why is that? Well, imagine I stayed if I stayed low, the biggest difference I could have is 3 minus 1, which is 2, which is no good. I need a difference of at least 3. So I'm not allowed to be low, meaning I must be high. Now there are further restrictions between these two, like 4 can only go with 1, for example. But we can say if this is low, this is definitely high. And once you're high, you need to go back down to low. So you always alternate. So I'm going to use green and purple to represent the alternation. And then once we know whether green or purple is low or high, then we can switch them to blue and orange, blue for low and orange for high. So this is my ambiguous colors where I just know they're different, and then blue and orange are when I know low versus high. Okay. Now, sometimes it's possible to spread the coloring. I'm not sure that I can on this puzzle. We know that this is 1 purple, 1 green. So I guess the point I should make is that there are exactly 3 greens and exactly 3 purples in every row, column, and box. Okay, so we might need to think about more restrictions here. So the 3 and the 4 are very special on German whisper lines. Why? Well, a 3 has only one buddy, only the 6. So wherever the 3 appears, it has to be surrounded by 6s on the line. And so as a result, it can't be in certain places. Now, can I find anywhere? Yeah, so like here, this can't be a 3 because this would be a 6 and this would be a 6, and those 6s would share a row. So I'll repeat a 6. Same thing with 4. 4 can only go with 1. So this can't be a 3 or a 4. So this is from 1, 2, 5, 6. Now, are there any other spots? It seems carefully drawn to not have many. That can't be 3, 4. 3 or 4, 3 or 4, 3 or 4. Okay. I don't think there's any more spots that can't be. There must be another in here. Maybe I should think about So with non-consecutive, there's something interesting about say, hey, this is low. Oh, actually, yeah. Yeah, that is interesting. So let's say this was 1, 2, or 3. What could this cell be? Oh no, it's not as interesting as I hoped. Well, a 1, 2, 3 next to a 1, 2, 3 can't have a 2 in it. It has to be a 1, 3 pair. That's kind of my point. Because if it had a 2 in it, the 2 would be consecutive with the 1 or the 3 that was next to it. So let's see. If these were low, 1, 2, 3, that might be interesting for the cell, right? So if these were low, then this is high, right? So this would be 5, 6, meaning this couldn't be 5. And what we're arguing here is symmetric digitally. We'll see. But this doesn't work because 1 or 3, whichever one it is, removes the 2, and now we have too many 1, 3s in the row. So actually, this isn't possible. These actually have to be high. So it must not be symmetric for whatever reason. Yeah, because we don't have the other extreme. We don't have the 6 available. So from 4, 5, 6, this would be 1 or 2, removing the 1. Now this is 3 or 5, removing this 2. So this would be 1, which is fine. And then 3, 5 removes 4. Wait, did I say 3, 5 removes 2? It doesn't. 3, 5 removes 4, making this a 5, 6, making this a 3, which makes that a 1. So that's what we have to do. Because these can't be low. Low breaks this cell. So they will be high. So let's just go through it again. This would be 4, 5, 6. And then that means this is low, meaning it's from 1, 2. Remember, it can't be a 3 because it would put double 6 here. So a 1, 2 here can't be consecutive with 1 or 2. If you have 2 consecutive options within a cell, it removes those same consecutive options from all the cells around it. None of these can be 1 or 2 because they would be consecutive next to each other, right? And so that's not a 1. And so now from 4, 5, 6, from 3, 5, that removes 4 because both 3 and 5 are consecutive with 4. So those can't be 4, leaving a 5, 6 pair, meaning that this has to be 3 because it can't be 5 anymore. 3 is now next to this, meaning this has to be a 1. So these are low and these are high. And then this has to be the 4 just to finish the row because this is low, this is high. Okay. I'm probably going to stop low-high coloring in just a moment, but I think it's still useful for here. So these are both a 1, 2 pair. And these are from 4, 5, 6. Right. This is also from 4, 5, 6. I think I'll get rid of my coloring at this point. Is there anything else I can do about this? All right, so we are going to need a 3 up here. The 3 can't be next to the 4, so that's out. If this was a 3, this would be 1. If this was a 3, then there's no consequence. We need a 4 up here, and the 4 can't be next to the 3. If this was a 4, this would be a 6. This wouldn't have no effect. Okay. So this can't be 5 or 6. It also can't be 1 or 2. So this is only 3, 4, right? It can't be 1 because 1's in the box. It can't be 2 because it's next to a 1. Could be 3 or 4, and it can't be 5, 6 because it's next to another 5, 6. Now 3, 4 can't be next to 4. This can't be 3 or 4. So this is from 1, 2, 5, 6, but obviously 1 is gone. So this can't be 5, 6 or a 1, or 1 or 2. So this is also 3, 4. That's a 3, 4 pair. So that's not a 4. So we have a 5, 6 pair, 3, 4 pair. This is our 2. All right. So 2's in one of these two. If this is a 2, that would be a 4. Should make that a 6. All right. What else do I have here? So this can't be 1, 2, 3, or 4. It can't be 1 or 3 because it's next to the 2. It also can't be 4. So this is from 5, 6 only. This is a 5, 6 pair now. So these are from 1, 3, 4. 3, 4 can't be next to 3, 4. So that's our 1. Leaving 3, 4 there. 3, 4, 5, 6. So this can't be 3, 4. So this is 1, 2, 5, 6. This can't be 5 or 6 or 2, 4. So this is 1, not 2. Could be 3, not 4, 5, 6. Okay. 1, 3 removes 2 from here. What else can we do? So up here, I need a 4, I need a 1, 2, and I need a 5, 6. That's kind of interesting. Because we can't put the 5, 6 here. We can't put the 1, 2 here. We also can't put a 1 or a 2 here. Okay. So this 1, 2, whatever it is, has to end up here in this box. If it's a 1 has to go up here. If it's a 2 has to go up here. Well, it can't go here because it's next to a 3, so it can't be a 2, and there's a 1 in the column. So this is never 1 or 2. And this is never 1 or 2 because it's next to a 1, 2. So this is our 1, 2, meaning it's not 4. That places our 4, and this is now a 5 or 6. So this can't be a 5, 6 anymore. So the 5, 6 is over here. This can't be a 1. So this is actually 2 or 3. It's either this 1, 2, which it can't be a 1, so it's only the 2, or it's this 3. It can't be the 5, 6. So 2, 3 removes 2, 3 from here, meaning it is 1, 5, or 6. This can't be 3 or 5 or 2. So this could be a 1. It can't be 2, 3, 4, 5. It could be 6. Interesting. That's a 1, 5, 6 triple in this row, right? It can't be 2. It can't be 3, 4, or 5 because of the 4. And so, yeah, 1 or 6. So 1, 5, 6 triple. So basically 3 in this. Oh, why did I remove 3 from here? Sorry, this could be 3. Never mind. I think I messed that up at some point. Okay, I'm glad I caught that. Like, what? I have a 3 corner mark there. Why didn't I think it could be 3? So anything else I can do here? Do we expand down? 4, 5, 6. This can't be 5 for what it's worth, because 5 would be either next to 4, 6 or be a 5. 3, 4, 2. This can't be 5 or 6. It can't be 4. So this is from 1, 2, 3. It's not a 1 either. 2, 3 removes 2 from here. So actually, now this is the only place for 2 in the box. That's quite nice. That gives us a 1 and a 2 and a 2 and a 3 and a 4. 4 can't be next to 5. So these are both 6. This is 3 and 5. This is 3 and 5. This is 6 and 4. We get our 5. We get our 6. We get our 1. We get our 5. That's 3 and that's 1. Okay, so I need a 1 in this box. I also need a 3 in this box. This column finishes with a 6. This column finishes with a 4. These 2 digits are the 2 and the 5. It's a 2, 5 pair. Let's just get these 2 digits. We need the 6 here. We need the 4 here. This is 2 and 5 and 2 and 5. All right. So, nice puzzle, PjoeterBliep. There were some interesting deductions to do there. Okay, so I promised to talk about what's special about non-consecutive in a 6x6 with standard boxes. Well, it's that we're always going to end up with evens or odds together. So in this case, we know this is odd. So what do I mean by together? There's a very specific way that they end up organizing. In fact, non-consecutive with a completely blank grid, 6x6, standard boxes, non-consecutive, you're going to have 48 possible solutions, and that's just going to be different permutations of symmetries here. And so we always would end up with, because we know this is odd, we're going to end up with 3 odds here, which is going to make all of these even, and it's going to make this odd. I'm going to use orange for odd and blue for even. And then you're always going to end up crossing a box. You have to preserve parity. So these will be odd. Yeah, these will be odd and these will be even. And then these will be even and these will be odd. And so preserve parity again. And you end up with this pattern. So this was forced just by having this cell odd. We're forced to have this pattern. So we've already reduced our solutions to, I think, 24 probably. So now I could pencil 135 and 246 and all of these, but I think we can just look at this German whisper line here. And I'm going to do this solve using this deduction, this thing I know about non-consecutive that unfortunately I can't sit here and prove to you right now. But with this, it'll trivialize the puzzle quite a bit. So these are from 246, right? But the 4 is not possible. So we're never going to put a 4 next to a 2 or a 6. And so this has to be a 2-6 pair, which means this is 2-6. Similarly, 1-3-5 can't be you can't use the 3. It's too close. And so that's going to be 1-5. This is going to be 1-5. Now, this is next to a 1-5 and a 2-6. So, yeah, I don't know that we can make that deduction yet. But we have some 3s to place. This is a 3. And then this is a 4. Just finishing off. Now, 4 can't be next to 3-5. That's okay. All right, how do we want to continue from here? Okay, so this next to this 4, we can't have a 3 or a 5. Both 3 and 5 are consecutive with 4. So to be odd, we need to be a 1, and that leaves a 3-5 pair here, 3-5. Next to this 3, we can't be 2 or 4, so we have to be a 6. And so then this is a 2-4. And I think this is one of the cruxes of the proof. It's not enough, but wherever the 3 goes, the 3 is always going to go with the 6 vertically. And I think it does force vertical roping for that reason. Because wherever the 3 ends up, it'll have to be next to the 6 because it can't be next to 2 or 4. So we're going to have 3-6 somewhere. And then we're going to have 3-6 here. And then we're going to have 3-6 like this. That's going to be forced. And here the 1-4 is going to force roping as well because 4 is always going to be next to 1. And so this can't be forced. So this is 4-1. And then this is 4. Oh, sorry. This is 4-1. And then whatever we discover here, that's also going to rope vertically. Now, whatever vertical rope we do, this will be a 1-5 and this will be a 2-4. Can I place a 6 down here? I'm not sure. This is 2-6. These are 3-5. I wonder if there's any like deductions I can make right now. 1-5, 2-4. This is 2-6, and this is 3-5. Okay. It's probably this line then. So we're either going to be 1-4 or we're going to be 5-2. There's got to be something else limiting us here. Do I have any consecutiveness that I haven't touched yet? Here, this 4 gives us the 1 here, and that chooses the solution, I think. So that's 1, that's 5, 1 and 5. The 1 can't be next to 2, so that's 4, that's 2, that's 2 and 4, that's 1 and 5. 5 can't be next to 6, so that's 2 and 6. 6 can't be next to 5, so that's 3 and 5, getting us 5 and 3, 2 and 6, 2 and 6, 3 and 5, 2 and 4, and that is actually the solution. So I could leave it as an exercise to you, but it is actually quite difficult. But it is possible to prove this sort of feature that you have to have the odds and the evens grouped together this way. Or you could swap, like the color. You could swap the meaning of these colors and say, okay, this top row could be all odds, and then this is even, odd, odd, even. And I think the fact that 3 always would have to be into a 6 is one of the ways to do it. But you have to prove that 3 has to be next to an even, which is something you still have to do. So anyway, the vertical roping is also extremely helpful in speeding up the solve. So this is why I don't think you should do non-consecutive on 6x6. Once that cat's out of the bag, it can be pretty trivial. You can ignore it like I did and have a nice solve. But in 9x9, you don't have anything like that. There's no like special trick in 9x9 for non-consecutive. All right, cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.